So whenever we are starting a new topic, it's always quite nice to have a real world motivating example to introduce the topic and to sort of make students feel connected with what you're trying to teach them. So this video is going to talk about the addition of fractions, and let's give a real world example. So when I go to school, right, I might take an apple with me, okay? And on day one, I am not so hungry before lunch, so I eat only 1/3 of the apple. I don't eat so much for lunch, so I'm a little hungry, and after lunch, I have 1/2 of the apple, okay? On day two, right, I'm slightly hungry before lunch, so I go ahead and eat half the apple. And then I have a decent lunch, and sometime after lunch, because I'm not so hungry, I eat 1/4 of the apple, okay? So now if I were to pose the following question, how much of the apple did I eat on day one? And how much of the apple did I eat on day two? And can I represent the amount of apple, right, that I ate on day one as a single fraction? And similarly, the amount of apple that I ate on day two as a single fraction, that essentially amounts to the addition of fractions. And we'll go ahead and see how we can actually work the algebra of this out. Okay, so let's look at the case of day one. Yeah. In day one, what basically happened was that you have 1/3 of the apple before lunch, and then you have 1/2 of the apple after lunch. So let's get a visual feel of this. So let's actually draw an apple, okay? My drawing of an apple isn't great. Well, let's just assume that's an apple. And so essentially what we've got is that before lunch, I've had 1/3 of the apple. So let's assume that that is approximately 1/3 of the apple. And then after lunch, I had 1/2 of the apple. So that is roughly 1/2. So before lunch, I had 1/3 of the apple, and after lunch, I had 1/2 of an apple. So what we do now is let's take the apple and break it up into 6 equal parts, which is approximately that. And let's label these parts, okay? So that's 1, 2, 3, 4, 5, and 6. So before lunch, I had 1/3. So I shade the equivalent area, which is that, okay? After lunch, I have had 1/2 of the apple. So I shade that area. So essentially what I've done is 1/3 is 2 of the total 6 pieces. So I write down 2 divided by 6. So these 2 pieces are 2 of 6 pieces. And this shaded region here is essentially 1, 2, 3 of the total 6 pieces. So that is 3 divided by 6. So that is just 2 plus 3 divided by 6, which is 5 divided by 6. So essentially what happens here is that on day one, I have eaten 5/6 of the whole apple. Okay, so let's look at the situation on day number 2. So what we have in day number 2 is that I was fairly hungry before lunch, so I had 1/2 the apple, right? I had 1/2 the apple before lunch, and then I had a reasonably sized lunch. So after lunch, I was not so hungry, and then I only had 1/4 of the apple after lunch. So let's go ahead and draw our apple. My diagram of an apple, of course, isn't great. But what we've done is that before lunch, we had 1/2 of the apple. So 1/2 the apple was eaten before lunch, and after lunch we had 1/4 of the apple. Okay, so now if we actually just break it up into 4 pieces, then before lunch we've had 2 of the 4 pieces. So before lunch we ended up having 2 of the 4 pieces, and after lunch we had 1 of the 4 pieces, so we shade that as well. And so what we do is we had 1 of the 4 pieces after lunch, and then we add them up, so that gives us 2 plus 1 divided by 4, which is just simply 3 divided by 4. So essentially we have had 3/4 of the apple within the day, half before lunch and a quarter after lunch. Okay, so what we've essentially done is started with a real world problem. Okay, and then we constructed a visual representation of that particular problem, and from there we were able to do some analysis and some calculations in order to deduce or basically get the answer to the question that we posed from the real world, right? So this way of sort of introducing concepts can be quite useful for children, where you actually start with a real world problem or a real world statement. If possible, show them a visual representation of it, and then go ahead and do the calculations associated with the problem that was actually posed.